And Nurin, we appreciate it again that you're coming and being with us today, and it's all yours.
Thank you. How you doing, folks? My name is Nan. I'm a staff solution architect at VMware. Let me go through this. My job at VMware is I'm focused on building solutions around VMware and Microsoft Business Suite, um, with SQL servers between them, so SQL Server Exchange, Skype for Business, and so on. And what does it mean build solutions? First off is writing best practices of how to run these applications on vSphere, or how would they work with VMware NSX and so on, and also solutions that customer can consume. For example, creating a network virtualization security for SQL servers automatically. So that's the kind of things that I do. Also go around and present at different venues with SQL Saturdays, VMUGs, VMworld, and so on. That's things I do. Just a few words about me. I'm a VCDX, which is a VMware Certified Design Expert. Was a VMware instructor for many years, and got all kind of acronyms as certificates in history. So this session is focused around how to architect a vSphere and VMware in a way that you can run SQL servers that are, performance is of highest priority. But before I go into, you need to do this or you need to do that, I've been asked, this question a lot by customers when I go in and talk with them about, SQL Server virtualization. Is what is that is too big or too large to run in a virtual machine? This slide basically shows what is the limitations of a virtual machine as of today, as of the version that we're running right now, which is vSphere 6. So with 28 virtual CPUs, up to 4 terabytes of RAM per virtual machine, um, above 40 gigs to a virtual machine, and over 1 million IOPS that we can. That's a study we did. We were able to put 1 million IOPS into a single virtual machine in storage IOPS. Now this only comes to show the high limitation of a virtual machine. Comes to show that there's almost no SQL database that cannot be consumed or cannot run and hosted on a virtualization platform. Now, even more than that, when we talk about the 1 million IOPS, and you can see at the bottom here, this is a study we did a few years ago to show just that run this amount of IOPS to a single virtual machine. The study, we were able to do that in under 2 milliseconds of latency, which in my view is the more important number, because nobody actually needs 1 million IOPS to a single virtual machine, but if you can do that in such low latency, just shows that on the storage stack, which is the concern for many customers when virtualizing databases, the storage stack overhead from virtualization is very low, and we actually put a number on that. The overhead on the storage stack should not be over 100 microseconds. That means basically, if you look at VMware monitoring tool or any third-party tool on the VMware side, and you're seeing latency on IOPS on the virtualization layer that is over 100 microseconds, that's considered a definite problem. So this just to show there shouldn't be any issue with virtualizing any kind of database if you are doing the right configuration that fits your database and fits the database requirements and fits the platform that you're running it on, the type of database and so on. And that's what we're going to focus our session right now. So, I'm going to run through all of these through the presentation, but this is kind of a cheat sheet of what do you need to do to run SQL for performance right on virtualization platform. Now, before I go into the points here and before I go into the presentation, make the distinction between of virtualization, or I would say two types of efforts to virtualize. Uh, there's the virtualization VMs, the virtualization that would do it in order to save on hardware and do which kind of moves resources between virtual machines. We overcommitted some resources just to have the highest density. This type of virtualization fits, test dev, tier 2 databases, not high performance production. So the other type of databases that we're going to concentrate the presentation on, databases that performance is of highest I would say performance and availability is of highest priority when you virtualize them or when you build them. When that is the requirement, when you want highest priority performance, for example, an OLTP database that serves customers, we set up the system in a different way. We set up the system by minimizing resource movement between virtual machines and minimizing or eliminating altogether any kind of overcommitment on resources. And that allows us to what I would call networking line rate performance, right? The near bare metal performance with the least of risk of having performance issues virtualized because we have in virtual machines. We don't want to have contention. Now, some might ask, so what's the benefit? So the benefits are, first of all, you save on hardware just by doing something called right sizing, and that's something very important. If we talk about, sizing a database on virtual machines, we do it differently than what we do on physical systems. On physical systems, when we, size a database and we size it, let's say for 8 CPUs, just a number that I'm throwing out there. So we're probably going to go with, I would say, 12 CPUs or more, and that's to compensate on any design errors and for future growth, because it's hard to add resources to physical machines. But on virtualization, we're right-sizing the machine. We would put the machine with 8 CPUs because it's very easy. Hold on. Close this. Sorry about that. Because it's very easy to add resources afterwards. So we try to right size as much as possible. So just by that, we save on resources. We don't over allocate resources. We put the right resources we need. But there's other benefits of like agility, the ability to move virtual machines around, doing all kind of neat stuff like backing them up and copy them and clone them. Just if you think about hardware upgrades that you need to do on physical systems, how hard it is, because a link between the SQL Server and the hardware it's running on with virtual machines is just a click of a button and we move the SQL Server to a new server. So all this type of things is the reason why many customers choose today to go with the virtual first policy, and they virtualize databases, whether the most critical databases or the less critical databases, they still go and virtualize almost everything. And I hope that makes sense. Now, after we went through that kind of disclaimer, let's go through the presentation itself. So these are the four things you need to take into consideration when designing your environment for high-performance databases. Then the first thing, obviously, is the physical hardware, right? There's things that you need to consider on the physical hardware, whether it's the hardware compatibility list, BIOS configuration, power configuration, very important, and other settings that we want to have enabled, like hyperthreading and NUMA, and I'm going to cover that in the next slide, of course. There's things we want to do on the E6i host, right? And things we want to configure on the virtual machine, or the way we want to set up the virtual machine to support the SQL Server that's running on it, and the stuff that we want to do on Windows and on SQL. Many of them would be the same things that you would do on a physical machine. But there's some kind of small tweaks that you can do on a VM on the Windows level and the SQL level that would make it work better on a virtual machine. So I'm going to go over all these things. So let's start with a physical server. Everything, as it says on the slide, rides on the physical hardware. So you need to configure the physical hardware to support the type of workloads going to run on it. And first thing you want to do is to make sure your hardware is fully supported by VMware. Reason is the hypervisor itself, hypervisor meaning the platform that runs the virtual machines, is the operating system actually that operates the physical hardware in some sense. So all the drivers are written by VMware as well. So if some hardware components is not supported by VMware, it might work, but you get a driver that is unsupported, and there could be some things that it's hard to anticipate what kind of problems you might get. So it's important to have the right stuff on your physical server, and it's very important to have the updated drivers, the firmware and BIOS as much as possible. All these things impact how the virtualization works. Now, those things we want to do, just like we do on physical servers, you want to disable unused physical hardware devices, and enable all the cool, interesting, and advanced features on the BIOS, like enable hyperthreading. That's one thing that's very important. Hyperthreading allows the hypervisor, the VMware hypervisor, which is called E6i. So it allows the E6i to have more scheduling opportunities and actually can increase performance. You want to enable NUMA, and I'll touch NUMA specifically in slides, in further slides down the road, but NUMA enabled. The way to enable NUMA is different on different hardware vendors. Some hardware vendors you need to just go and enable NUMA, or another hardware vendor it says something like disable memory interleaving. Either way, enable NUMA. In regards to power scheme, our recommendation, and if you read the best practices guides for SQL, and that's something I would recommend, you see that is to set the power setting to always controlled, and what we also recommend is to go on the VMware side on the E6i level and configure it to high performance. This is adequate for your high performance VMs because it prevents all kind of tricks to reduce power from going on. We want to minimize the time the VM is waiting for CPU, so high performance would be the choice. Just on that doesn't mean that you have to set it always controlled. Some customers may choose to set high performance on the BIOS, and that is also fine. There's sometimes differences between the two configurations, but obviously there's not a lot of time to go into that in this session. So change the power setting to always controlled, enable the turbo boost, disable C states and C1E and so on, and enable all CPU cores. That's kind of the thing about the hardware setting. In regards to hardware assisted, this is something that today's servers is enabled, but I would definitely check to see that is enabled. Now let's go into storage, and storage is important for many customers. So, when we look at the storage stack, what we see on the top, what we see in the diagram here, we see on the top the virtual machine itself. The virtual machine itself is running an operating system, which is Windows in our case. Even though Microsoft has announced they're going to be SQL and Linux, it's still yet to be out, so we're talking about Windows. and SQL is installed on it. And in the virtual machine, we have something called the virtual SCSI. And the way that storage works in virtual machines, it's no matter what's the underlying storage architecture, whether it's a NAS, it's a SAN device, you're using fiber, iSCSI, what have you, um, the virtual machine itself talks with its virtual disk, which is a file, using regular SCSI. And it has a virtual SCSI adapter attached to it. Um, under that, we see the Vim kernel. The Vim kernel is just another name for the virtualization platform, which is another name for the hypervisor that is called ESXi. So that is VMware here. And under that, we have your traditional or non-traditional sometimes storage stack. In this case, in the diagram, we have switches, front-end ports on a SAN device and a SAN device in the bottom. And that's what we usually see with customers. Now, what's important to understand here is that there's a lot of factors that affect in performance in this stack, right? From this point on down, this is almost no different than physical. I mean, you have to have this configured in a way that it can accommodate the requirement of the servers that are accessing the storage stack. And we're going to touch on that as well. But what I want to specifically talk about here is something that's very important and sometimes it's overlooked, which is queues. There's queues all around here. There's a queue on the virtual SCSI adapter, just like any operating system. There's a queue on the SCSI adapter. There's queues in the Vim kernel. There's queues in the switches. And there's queues in the front-end ports of the storage device, and so on. So there's queues all around. And setting up the right queue depth is highly crucial. So the first recommendation is usually, if you have a queue, and a queue, the reason we have queues is to allow multiple simultaneous IOs to go down the path, and if there's slowness going on, to start to queue up, so we can still send IOs. That's why queues are there. But the problem with the queue is that when the queues start to emerge, start to happen, it slows down the entire stack. So when it comes down to queues, there's two things to reduce the risk and increase performance. One is increase the queue. So this is the response time. The more the queue time and the service time goes up, right? So one thing you can do is increase the queue. So let's say in our case, when we talk about the virtual SCSI adapter, the default one is called LSI Logic, and the default queue depth is 32. And there's another one called PV SCSI that I'll talk about soon. It has 64. So one thing you can do is increase the queue depth, let's say from 32 to 64 or to 128, or add additional queues, right? And have more parallelism. So let's see how that goes. So we have the guest device here. We can add up to 4 SCSI adapters to the virtual machine. That will create more parallelism for the operating system. So when the virtual machine works with this virtual SCSI adapters, it can send IOs to 4 paths. If I'm going to put the 4 virtual disks that are attached to the 4 SCSI adapters to 4 separate LANs and maybe underneath even 4 storage devices, then I will get more queues, more parallelism, and more IOs that I can be serviced by the storage. Now, it's very important to understand that if we go and increase queues, it affects the entire system. So designing around queues is very important. And let me go back just one slide to show. So if I'm going to increase the queues here in the virtual SCSI adapter and add more SCSI adapters, I can send more IOs down to the storage. But we have the front-end ports here, which is the storage next, kind of, right? And we have the LANs queues as well. What we want to do is design around this. So you, the customer, need to work with the storage vendor first of all to design around the front-end queue front-end queues. You need to design the storage stack in a way that you won't cause a situation of oversubscription on the front-end ports. So if this can support 10,000 IOPS at any given second, then you need to design in physical servers will not send more than that, or if they do, that it's managed in some way and monitored in some way that it won't happen. And then from that point on, we design upwards and design our systems to be able to send as much queues as we can, as much IOs as we can, without plugging the queue. So I'm gonna stop here for a second and see if there's questions.
No questions at this time, so continue on.
All right. So let's go into actual recommendations. So from virtual SCSI adapters, as I said before, there's two types of virtual SCSI adapters you can use. There's LSI Logic SAS and there's PV SCSI. These are the two that usually are being used on the virtual machine. Our recommendation is to always use the PV SCSI wherever possible, especially on high performance when the high performance is a requirement. PV SCSI is what we call power virtualized device, and power virtualization is basically a device driver that doesn't try to mimic the physical world in any way. It knows that it lives in the virtualization layer, and it works more efficiently in the virtualization layer. So the PV SCSI, in any case that I/O is intensive in a requirement, would work better. And PV SCSI comes with a 64 queue depth by default, and 254 per adapter. So it's 64 per disk that's a virtual disk that's attached to it, and 254 for the entire adapter. If we have a virtual machine that IOs is very intensive on it, and you want to increase the IOPS, so you would want to increase the queue depth on the PV SCSI, and that is explained in this knowledge base here. Now, that's not all. We can also add additional PV SCSI adapters. As I said before, default you bring it with one. You can add additional 3 adapters, so up to a total of 4. Usually what we see customers do is they have the boot device of the virtual machine on LSI Logic. Reason is LSI Logic has the driver built into Windows, so it makes it easier when I go and install Windows or deploy Windows to have it boot from something that the driver exists by default in Windows. But that doesn't mean that that's the only way to do it. You can provide, when you create your Windows template to be used with SQL, you can provide the PV SCSI adapter driver from VMware Tools and allow Windows to boot from that driver and have 4 adapters. But what we see customers mostly do is LSI Logic as the boot device, and the other 3 PV SCSI adapters having the different data disks, log, tempdb, and data spread on those PV SCSI adapters in a way that will balance out the IOPS as much as possible. And so here's the setting that is defined in this knowledge base to increase the queue depth of PV SCSI, and you want to have more than one adapter. Another question that customers sometimes ask is, should I have large data stores? And when I say data stores, I mean LUNs. So large LUNs or smaller LUNs. So the difference between virtualization and physical usually is that on virtual environment we can have multiple virtual disks in one LUN, and physical environment we have one-to-one mapping between disk and a LUN, because the physical servers do not use virtual disks, but they basically use the raw devices. When we can have multiple virtual disks in one device, that helps us is management. But then comes the question, how large should I have the data store? Should I have the data store up to 2 terabytes, up to 4 terabytes? So the first answer would be that is vendor and even storage model specific. So you need to design it around the storage, but more importantly, you need to design it around the workloads that they're going to reside on that LAN. The only problem that we see with very large data stores is if the storage cannot accommodate for the IOPS that the virtual machines are sending, uh, and it's not adequate to the IOPS capability or to the queue depth of the LAN device. Additional storage devices recommendations. Usually they don't. The best practices is to have the LAN up to 2 TB or 4 TB of size, and that's because the queue depth is usually 64, and that's kind of a rule of a thumb that if we throw too many VMs on that LAN because it's too large, then we can have problems with queue depth. If you look at all-flash arrays that can have a much larger IOPS capability and have queue depths of not 64, of 256 and even more, in those cases you see the limitation relaxed a bit and have 20 TB plans. So it depends on the storage device and dependent on the workloads you're going to run on it. Is it very intensive workload? It's going to send a lot. You might want to have the LAN size small. As for using IP storage, such as iSCSI or NFS, NAS device, no, not NFS. You don't have to be NFS. It can be other things if you connect it through the Windows side. Then using jumbo frames can give you better performance than just using 1500 MTU. So here's the setting to go and change the Vim kernel LAN device, the Vim kernel LAN device queue depth. You need to follow the vendor recommendation as well as for the HBA configuration. So we have these knowledge bases that you might want to follow when you design around that. Or if your VM admin is designing around that, the environment for your database. Just want to touch one more point regarding a technology that exists in vSphere called storage IO control. Now, I mentioned that we can have a situation, well, most cases, we have a situation that we have a data store that multiple VMs reside on from multiple servers. And that's fine, right? If we design the LAN and the storage device to be able to accommodate for the requirement of all of the aggregated requirement of all the VMs that reside on it, we should be fine. But what happens when there's a problem? What happens when two VMs start to get crazy, hammer the storage in a way that affects other VMs, increase their latency, and affects the performance? How do we protect from that? And that's where storage IO control comes into play. This is basically a technology that first and foremost provides fairness in accessing the storage. So if this case happens and those two VMs get crazy, storage IO control can cap them on the cluster level, not on the one server level, on the cluster level, can cap them and allow your important VM to still get fair access to the storage. Something we call the noisy neighbor problem that eliminates. It's even more so, we can do small things with it. We can actually set shares is setting priorities, very accurate priorities about which VMs needs to get more access proportionally to other VMs. But even if you don't set that up, it will still make sure that no one VM or two VMs or whatever affect all the VMs that resides on that data store. And that is very important to allow you to have that confidence in minimizing the amount of LANs you're managing and having better and easier management on the environment. In the latest versions of vSphere, we added the capability even to have IOPS guarantees. And it works in a very interesting way. It's a very good feature. I would urge you to go and look into that and check with your VM admins to see if they have this feature enabled. If they do want to enable it, they should go through the best practices to make sure there's no unsupported configuration for it. For example, unsupported configuration would be so in order for this to work, the vCenter, which is the management system for VMware, needs to have the ability to control everything that touches the physical device here. So if latency is being, so let's say under this LAN, there's physical disks that are being used, let's say, but stuff that is physical, or an environment that is not managed by the same vCenter, and latency goes up, the vCenter cannot cap the right VMs, so the physical servers. So if it can control it, storage out control cannot work correctly. So I would urge you to look into this, as this can save you from really bad day, but still make sure you follow the guidance of how to do it. Question that comes up, and I'll touch really briefly on this: VMFS versus RDM. Just VMFS is the VMware file system. RDM is we allow a VM to utilize devices without having that layer of virtual VMFS. Um, the answer is there's no real performance benefit from using RDM or using VMFS. They both would perform the same. VMFS will allow you to have multiple VMDKs, and will allow VMDK is a virtual disk in VMware, so it will allow you to have multiple virtual disks residing on one volume, while RDM will give you the one-to-one mapping and full isolation. Then it's still hard to manage everything so that every VM is RDM. So the recommendation is to use VMFS wherever possible, and only use RDM when that is required. And the only reason that I see it is that might be required is when you use Microsoft cluster shared storage, such as FCI, on top of VMware. That's the only situation today, as of today. It's going to change in the future, but that's the only situation that requires an RDM. For any other case, I would definitely use VMFS. So what about the disk layout? So how would you set it up? So for a SQL server that's running on a virtual machine, it's not different than a physical machine in the regards that the different components of SQL has different IOPS requirements, and you want to set up the physical underlying storage to accommodate for that. So for example, logs usually are not usually, they're very sequential, and you want to have it on disks that support that type of IOPS, type of workload. TempDB usually requires very fast storage, as fast as possible is good. So you want to set that up the same. Now, what is different between physical and virtual? As I said before, on virtual you can have multiple VMDKs on one storage device, on one data store. So you want to be able to accommodate for everything that resides on. So in this case that you see in front of you is kind of a realistic kind of a configuration where you see a SQL server that has multiple mount points, and on each mount point has multiple disks. Each one supports different components of the SQL server. That works through four virtual SCSI adapter. In this case, we have single logic LSI logic that supports the operating system, and all the VMDKs that supports the data reside on multiple PV-SCSI adapters, which in this case we try to spread them out as much as possible so it balances out on all the IOPS of the vSCSI adapters. What you see here is kind of a general representation of the disk. It doesn't have to be data TempDB. It depends on the workloads, depends on the database, and depends the way it works. But the general notion is to spread it SCSI adapter. Now, these will be represented by actual VMDKs, which are files that reside on data store that are comprised of LUNs, and underneath here it's going to be comprised of physical devices. So what we set up here is actually, it's kind of bins, right? Where these bins are configured to support the VMDKs that reside on them. And we can have multiple SQL servers utilizing the same data stores. We just need to make sure these data stores and these LUNs, they can support, as I said, the aggregated requirement of all the VMDKs that reside on them. And you should be fine from a performance perspective. If you're going to overcommit on IOPS, if you're going to set up, so I've seen many situations with customers. Sometimes, a customer would go on a physical machine, will set it up in a certain way by setting up a separate disk for logs, separate disk for TempDBs, separate disk for data, and it's going to be physical disk, and it's going to set up correctly. And when virtualized, it's going to move it to a shared storage environment where multiple virtual machines are sharing the same underlying physical storage device. And let's say storage group or aggregate in NetApp, whatever it is, and doesn't understand why performance is not the same. So on the storage side, physical and virtual, then basic notion of consumption and of requirement and consumption is no different than physical to virtual. You just need to make sure it supports. Before I move on to compute, do we have any questions? All right.
Go ahead. We don't have any questions. Wait just a minute. We got one question here. Are you stating that each data store in a SAN bay is a SAN bay itself?
No, obviously not. A data store is a LAN. Well, it's not the same. You can have multiple data stores in a LAN, but it's not something that no one does. So a data store from our perspective is a LAN, a logical unit on the SAN, and a LAN is another abstraction layer on the storage. It can be multiple disk groups, so it can be multiple things on a SAN. But data store is kind of a LAN. Kind of thing.
Okay, no other questions.
All right. Let's talk about the compute, which is the CPU and memory. So first thing I want to talk about is NUMA. Now NUMA, what is NUMA? NUMA, non-uniform memory architecture. So if you look at the way CPUs evolved throughout the years, previously CPUs were with CPU vendors like Intel tried to increase the speed of CPUs as much as possible. And then they encountered a roadblock by the CPUs hitting too much, so they started adding cores, right? When we started adding cores, we come to another situation where the access from the cores to the memory became the bottleneck. So think about a CPU with multiple cores on it, and all the cores are trying to get from the same bus to the memory. And that became kind of a bottleneck, it slows down the system. So non-uniform memory architecture came up, and that basically creates so this is it. Basically, we have a processor with multiple cores on it, and each processor here has its own memory that's considered local, right? So let's say we have so each NUMA node here in this 45 gigs, and I don't know, and 8 CPUs, right? Sorry, it's 96, yeah, it's 45 each one. So if I'm going to set up, let's go back for a second. If I'm going to set up a VM that's going to utilize more than what we have locally on the processor here, so it's going to be spread out through two processors, two sockets. Some memory would be accessed remotely, and that can degrade performance. So on VMware, when you set up the virtual machine to the size of the NUMA node, so let's say in this case would be 8 CPUs and 45 gigs of RAM up to that point, E6i will take all the processes and will make sure it's local without you on the SQL side or the Windows side need to do anything. So many kind of applications that are not NUMA aware, such as Exchange, for example, and others, that sometimes it's hard to manage NUMA on them to extract every bit of performance that you want to extract. If you set it up to the size of the NUMA node, it makes it easier for the scheduler to put everything in the node. Fortunately, SQL is very NUMA aware and is very good with that. For that, we have a feature in VMware called Virtual NUMA. And what happens is if you want to create a VM that's larger than a NUMA node, and by default larger than 8 CPUs, what it will do, it will spread it out. It will spread it out on the CPUs. Let's say, where is that? I have that. Here. So in here, this is the case here that we have two NUMA nodes, as you can see here, and the VM that is larger, it will spread it, cut it by half, and in this case, and will create two virtual NUMAs on the VM level. and we'll take each virtual NUMA node and we'll place it locally with its CPUs and memory to be used on the same NUMA node. And the operating system, which is Windows in this case, will be exposed to this architecture. So SQL itself will be able to utilize the virtual NUMA that is by VMware managed by the physical NUMA. So what we get here is the ability to do either set up a VM to the size of the NUMA node and allow the VM to, like in this case, the NUMA node and the VM to allow TE6 to manage all the CPUs and the memory to be local, or have a wide NUMA VM and have virtual NUMA create a virtual NUMA node and expose that to the virtual machine and allow SQL to take advantage of that. The recommendation, if you read the best practices, is usually to have the size of the NUMA node. Reason is it makes it easier for the scheduler to do to make sure all the VMs are local, and as the more the local they are, the more performance we extract from the server. But again, that doesn't mean that you can't have a wide NUMA VM. If you do that, you have virtual NUMA working for you and making sure everything is performing. In any case, it is easy to go and monitor to see what's the level of locality you get when you have virtual NUMA without virtual NUMA. There's a tool in vSphere in E6i called E6 Top, and there's also monitoring tools that come from the outside to E6 that can show a counter called NUMA locality, and you can see there. So if you have performance issues, you can actually see if your locality is less than 100%, which will indicate that memory might be accessed remotely from the remote NUMA node. So, so it's kind of the best practices. I already gone through this. Let me see. Yeah. One thing that I want to mention is there's a feature in VMware that's called CPU hot plug. CPU hot plug allows you basically go and check the box on the VM configuration. It allows you to add CPUs on the fly to the VM. When that's checked, virtual NUMA is disabled. So the recommendation is to not check that. So I see customers sometimes they don't know that they disable virtual NUMA. They go and check the box on the template, and all their VMs are set with CPU hot plug. The recommendation is definitely not to do that. Don't use CPU hot plug in high performance production workloads. That eliminates virtual NUMA, and if you go wide NUMA VM, you basically reduce the performance of your SQL server. Sorry that I'm jumping around. Another recommendation, there's a setting called cores per socket. So we can go on a virtual machine and set up, let's say we set it up with 8 CPUs, we can set up 8 sockets, or we can set up, let's say, 1 socket with 8 cores, or it can be 2 sockets with 4 cores. We can play around with that. And that was very useful in the days that SQL was licensed per socket and not per core. And customers love that feature, right? It saved them on licensing, which is no longer the case. SQL is licensed per core these days. And this setting can actually degrade performance if it's not handled correctly. So the recommendation is always to use cores per socket as 1, which means if you need 8 CPUs, use 8 sockets rather than 8 cores. And if you feel that you want to change that, I would make sure that it aligns with the NUMA architecture. But generally speaking, and if you read the best practice, is to avoid playing with that feature. Just use 1 core per socket. Should work for most workloads. Another thing that sometimes is overlooked, this is a feature actually in Windows that's called core parking, and the recommendation is to disable that. Even if you read Microsoft recommendation on that, is that this feature does not work well. It doesn't save on power and can actually degrade performance. So to disable core parking, and here's a link to the article by Microsoft that it doesn't even save power, and here's the link on how to disable it. But basically speaking, you go into Windows, you set high performance, and you run a command, and that disables core parking. But that is another best practice, which is actually on the Windows level to disable core parking. And what happens is with core parking, it goes and tries to put a core to sleep if it's not used. Now, since the VM cannot actually stop a core because it does not control the actual CPU, when it sends a command to put a core to sleep, the hypervisor just deschedules the core from that VM when it sends that command. And when the VM needs it back, obviously there would be a bit of latency getting it back. Doesn't matter if there's not a lot of work commitment, there would be a bit of latency going on. So we want to eliminate that as much as possible, especially take an OLTP database that's processing tons of transactions that are customer facing, very critical for my business. I would want to minimize the amount of latency waiting for the CPU as much as possible. And this would be very important to do. There's one more thing very important that I forgot to mention here. And the best practice, I would call it the best of the best practice to use, is not overcommitting on the physical CPUs when the system is just being deployed. So think about this physical server with, let's see, I have an example here. Think about this physical server here that has 22 CPUs. 22 physical cores. Eliminating hyperthreading aside right now, we're talking about physical cores. If I'm going to deploy more than 22 virtual CPUs on top of that, even if I'm creating the 23rd virtual CPU, I am creating contention. I'm introducing a fight between two virtual CPUs who are going to access that core first. When I'm doing that, there's a risk of setting up latency for my database. So if your database performance is of highest priority, you want to eliminate that. So when you go and deploy that server for the first time, you need to make sure that the physical server that VM is being deployed on does not overcommit on CPUs. And obviously you can monitor that through over time. And if you decide, let's say, that it's stable for a few weeks and it works very well, then you look at the density. There's tools from VMware, for example, like VROPS, that can tell you if there's waste of resources there. You can condense the server a bit more and maybe add more servers, more VMs on that physical server. But generally speaking, more virtual CPUs than physical cores creates contention, and you want to reduce that. You want to minimize that upon deployment of the VM. So we're running out of time. I'm gonna move forward with this. In regards to memory, so memory on virtualization is a bit different than memory on physical. We have an additional layer of memory here, which is the physical memory that's allocated to the hypervisor, and there's memory then that's allocated to the VM itself, and the VM itself, the guest, is allocating memory to the guest. So what we want to do is there's a feature in the BIOS called Memory Hardware Assist that helps memory be managed on the chipset of the server. You want that enabled. That basically that basically enables the ability for the chipset to understand the virtualization layer as well, and reduces overhead in memory management. Another thing we want to do or consider doing is utilizing large pages with SQL. And now large pages, what it will do, it will there's less pages to manage, and it reduces the CPU overhead, and basically can provide better performance. There's a downside to it, that it can actually prolong the boot process of the VM. So if you're considering using large pages because that fits your workload, I would check to see that it does not violate your SLAs for boot up on that specific SQL server. One important thing that we can do with memory on virtual machines that high performance, especially databases like SQL, is to set up memory reservation. Memory reservation basically tells the hypervisor that the memory that's allocated to the virtual machine is always physical. It's not swapped out and cannot be reserved by other VMs. It's a guarantee. Now, the most important best practice for virtual machines and memory is not to overcommit on memory on the physical server. Just like with CPUs, we do not want to allocate more than memory than what we have, minus what the hypervisor needs, let's say 4 gigs of RAM. We don't want to allocate more than that. So if I have 128 gigs of RAM on my physical server, I probably don't want to allocate to virtual machine more than 124 because otherwise I would create contention. When I'm not over allocating memory, the, the memory reservation does not technically do anything because memory is not overcommitment. There's no risk of swapping happening in the hypervisor. But I still recommend using memory reservation in that case because it future-proofs your VM. So if anyone ever moves another VM to your server or changes configuration, there's no way that that VM is going to lose memory or be swapped out. So you want to set up memory reservations for your VMs. There's another feature in virtual machines in VMware that allows us to hot add memory to the virtual machine. This is a very useful feature. It requires you to check a box. And since vSphere 6, version 6 of vSphere in VMware, does not have negative side effects, perhaps maybe it allows you to size less accurately. So I would say having hot add memory should not be a good strategy for sizing. You should size your VMs in the right way and not rely on hot adding. But it's a very useful feature because if you need to hot add and then you change your max memory configuration, that allows you to add memory on the fly to the virtual machine and to your SQL server, and allows the SQL server to consume that memory on the fly. So it's very useful to be used. Time check. How much time do we have? Okay.
You have about 7 minutes, so you're doing all right.
All right. Not a lot. So I'll skip through the less important thing and keep the important thing in. So in regards to network, sometimes network is overlooked, and the reason is it's not usually the resource that that's limiting us. Usually network is abundant, but that depends obviously on the workloads. In regards to network, you want to enable or have on your physical NICs as much as possible advanced features like DMA, scatter and all kind of offloads technologies is very important to have. One thing that we recommend is using a device driver on the virtual machine that is called VMXNet. Now, if you remember previously in previous slides, I talked about power virtualized SCSI devices. This goes the same for Ethernet adapter. We have an Ethernet adapter called VMXNet, which is a power virtualized device driver, and the recommendation is to use that across the board. That would definitely work better than your E1000 that exists in VMware, the virtual E1000 that tries to mimic the physical E1000. VMXNet works better in any case. As far as I know, there's no downsides to it. Use it at any time. Another thing that you want to consider is the load balancing. The load balancing configuration you're going to have on the physical layer of the E6i server or the vSphere. You can utilize multiple algorithms on how you want to use the network cards. So I don't have a lot of time to go into that too deeply, but think about having E6i server multiple NICs, and when a VM tries to communicate, the E6i needs to decide from which NIC it will communicate. And there's multiple algorithms to choose from to make the E6i to work with the teaming on the physical. One of them is called load-based teaming, and that is the only algorithm that actually looks at the physical NIC load, and if it sees that the physical NIC is overloaded more than 75% for more than 30 seconds, it will actually move networking of some virtual machines to other physical NICs. So that would be the recommended load balancing algorithm. But in any case, this is something to be worked out with your network admin. Maybe there's other practices or policies of what to be, but just keep that in mind that we have that ability of having load-based steaming. And this is here is very important. To keep VMware tools up to date at all times is very important. RSS, just one word about RSS, receive site scaling. There's a nice graphic. So this is what receive site scaling is. You got CPU 0 on the virtual machine processing all networking, and the other CPU is not doing nothing. And that is not efficient. So we want to enable receive site scaling, and that is done in two places. We do it inside Windows at the NIC properties. So you right click on the NIC, you go to the NIC configuration, you go to settings, and you enable RSS. And you want to do that at the Windows kernel, which is usually enabled, but it's something to check if you have performance issues by running these commands. So the best practice is to enable RSS. Just want to say that all these best practices that I'm going through, all these design points, all exist in our best practices guide. So if you run SQL on VMware best practices, you'll find that guide. Everything I'm talking about is written there. One more point that I want to touch on is should I use Microsoft clustering on VMware or not? And the answer is, if you need to, then yes. VMware has availability features that are built in inherently in the virtualization layer, but they do not come to replace what Microsoft clustering can do for your SQL Server, whether it's doing rolling updates or the RTO that it provides, which is seconds of downtime in case there's a failure, and the ability to monitor on the app level. These things, if those are needed for your virtual machine, for your SQL Server, then definitely we fully support clustering. There's no limitations there, and it's actually very complementary with the VMware embedded availability features, because what happens is if you have a Microsoft cluster on VMware and the server fails, and Microsoft cluster takes care of SQL Server, moves it to the other side, then VMware will actually recover your failed node. So it keeps the automation of the availability and increases SLA. So whether it's availability groups or FCI, both are supported. So WSFC is very supported. There's a knowledge base and there's a guide, basically guides for the best practices and the different availability options that you have. Definitely check that out. At the end of the presentation, I have this slide. Now we can use something called vMotion in VMware. So you can move a SQL server from a physical server to another physical server with no downtime. And in vSphere 6, we even enhanced that to have that remotely from data center to data center. So you can move a SQL server on the fly from one to the other. And the RTT, the round trip time between the data centers, can be up to 150 milliseconds, which is a lot. Think about, from Las Vegas to New York, moving your SQL server. Not go into too deeply into this, just want to keep you aware of that capability. This is a major reason why many customers choose VMware, because of this ability of moving stuff and how dynamic the system becomes when it's virtualized. Right, so just one word about clustering on top of VMware. If you're going to use Microsoft clustering on top of VMware, the default of WSFC timeout for heartbeat is 5 seconds. If you do vMotion, it might trigger a failover. It depends on different different causes. You can check that in the paper that I wrote about SQL Server availability on VMware. But basically, it can happen. So the recommendation would be to go and increase the threshold to same subnet to 10 and cross subnet to 20 and so on, so that it eliminates or reduces the risk of having unwanted failovers of Microsoft clustering in case of vMotion. That can also happen if you back up, right? When you have backup SQL Server, so you need to take consideration. And here's a few resources. We ran out of time, but here's a few resources that can help you do design or learn about what you can do on VMware. What I suggest is there's two main guides to look at. There's the SQL Best Practices Guide, which covers everything that I spoke of and a lot more about what can you do to design for performance and how to do it and what's the best practices. There's also a study that we did with SQL Server and vSphere 6 that goes very deep to some SQL configuration stuff that we did in a study to make SQL as performant as possible on vSphere. And there's also the availability guide, which I should have here. Um, I might have missed this link, but if you SQL availability guide, find it, and that covers all the different options you have to create an available SQL Server on vSphere, whether it's for disaster recovery or high availability, and also covers some best practices for Microsoft clustering on vSphere. And that is all for me today. Thank you very much for attending, and if there's more questions, I have a few more minutes. Let's see.
We got one other question, Nuran, and great presentation today. I appreciate it. For everybody that's online, it is being recorded. So we'll get it up on YouTube, and then we'll see also if we can get the slides from Nuran, and I'll get those posted out there also. The one question we have, does hyperthreading helps in the virtual environment? Does it help in performance in the VM?
So yes, hyperthreading does help. It does not provide additional CPUs, obviously. These are the logical construct, but the E6i knows how to take, the E6i being VMware, knows how to take advantage of hyperthreading and to provide more performance, and it also provides more scheduling opportunities. So if the moves virtual CPUs from to another, with hyperthreading, there's more options to do that. So yes, at any case, and I don't know of any other case, at any case, you should just enable that in the BIOS.
All right, sounds great. Well, thanks again for a great presentation. I think this is the first one I've seen actually on the hypervisor side of how to set it up. So I appreciate it. I hope the audience likes it too. And thanks again, and we'll be talking at you later.